Before we begin the video of our experiment, we first need to address a few safety concerns in order to have a successful and safe experiment. This video contains a variety of chemicals which can be harmful if they are not treated correctly and with safety. This is why we must wear goggles at all times while doing this experiment in order to prevent any eye injury that these chemicals might cause. Additionally, we must never mix a solution that we've taken out back with the stock, for it might cause a harmful reaction. Lastly, we must never smell these chemicals or put them in our mouths, for they can be very dangerous. First, we must measure 20 grams of starch in order to create a starch solution when mixed with water. Now we will add these 20 grams of starch into half a liter of water and stir it thoroughly. Taking a half a liter of water and placing it on a hot plate to increase its temperature in order for it to boil. Now this boiling water will be mixed with our previous half liter of water and starch in order to raise the solubility of the starch with a greater temperature. While dealing with hot glassware, always make sure to have proper equipment to not burn yourself. Now we will measure out enough sodium metabisulfite to create a 0.1 molar solution in 1 liter of water according to our calculations. Now we will take the measured sodium metabisulfite and add it to a liter of water carefully so we don't spill any. In order to create different solutions of potassium iodate, we will take the stock solution, which we will then dilute. Iris is now creating one of our few potassium iodate solutions using the M1, V1, M2, V2 calculations that we did to make sure that we had correct and ideal molarities for the iodine clock to work properly. Now Iris is measuring out 30 milliliters of the starch solution that we previously created. It is very important that you make sure that the starch is still soluble, as it will sink to the bottom if you let it sit out for too long. Now, after rinsing the funnel, I will measure out 30 milliliters of the sodium metabisulfite. Now that we have all of our solutions ready, we will begin the iodine clock experiment. We will begin by adding the sodium metabisulfite and the starch solution. By adding the potassium iodate, the solution will change colors. Although it may seem like an immediate change to the naked eye, Now we can see in the slow motion that it is slowly turning to black due to the different concentrations throughout the solution. Now you're probably wondering, how does this experiment work? Well, once you mix all three solutions together, a variety of reactions are taking place, but once the reactants are used up and can no longer accomplish these intermediate reactions, the starch and iodine that is left behind and form a complex which has a very definite blue-black color. Now that we've broken down the experiment, we will try it with 6 different concentrations of potassium iodate. As you just saw, this experiment shows that the concentration of our solution is directly related to the rate of the reaction, showing that the more concentrated the reactant, the faster it will occur. However, it's very important to get your molarity calculations correct, otherwise something like this might happen to you.
2 hours later. Three hours later. 6 hours later. Two 2,000 years later.
Now that we got the hang of the experiment, we decided to have some fun and create a game. We made 3 different solutions of potassium iodate and shuffled them around just so we didn't know which was which. Then we will play rock, paper, scissors to see who chooses first. But remember, always wear goggles.
Ini paling mo. Yeah, go ahead, Iris.
So
Pick this one.
Okay, then.
Okay then.
Okay. On, Iris. 3, 2, 1, go.
At this moment, Gio knew he messed up.